Now the second speaker, we have a question before he starts. Can we irrigate using saline water? This is the question. It is very important to know that when you irrigate with saline water, the salt concentration increases in the soil, and it has to be kept under certain concentration. But luckily that when the salt concentration increases, the plants start reducing the intake, and then some water is available for washing the soil and so on. So this experience of using saline water in drip irrigation will be presented now by Professor Kang. No, let me first read just wait. Let me read the bio. I tried yesterday to summarize the bio, but it seemed that the experience of Professor Kang is tremendous. So maybe I skipped some parts of your bio. Professor Kang obtained PhD in 1997 from United Graduate School of Agriculture Science, Im University, Japan. Obtained his master in 1994 from the School of Agriculture Science, Kagawa, University, Japan. Obtained his bachelor degree in 1986 from the Department of Soil Water Conservation, Beijing Forestry University. Professor, Institute Geographic Science and Natural Resources Research, Chinese Academy of Science, CES, Beijing, China. He is Distinguished Chair Professor of the Chinese Academy of Science, Professor at the University of the Chinese Academy of Science, Vice Chairman, Micro Irrigation Branch, China Association of Irrigation Area, and Pre-Director, Key Laboratory of Water Cycle and Related Land Surface Process, Associate Editor, Resources Science. Professor Kang has a long history of research in the field of water cycle and soil, plant, atmosphere, continuum, space, SPAC. I will go to the end. Professor Kang has made international known achievement, both theoretical and technological aspects of micro irrigation and sprinkler irrigation, drip irrigation with saline water and saline soil utilization. He published more than 270 papers, obtained about 3 national patents, 9 software copyright, and he was one of the main members set 2 national standard and 2 national professional standard. Thank you very much. Please go ahead.
No. And first one. Okay. Yeah, it's okay.
This one is better.
Okay. Good morning, ladies and gentlemen, and all of the friends and the new friends. It's my pleasure to give a presentation here to introduce our research results as a drip irrigation technology with saline water. So, my name is in passport is Yuehu Kang, but if you check my publication. So please use the Yuehu Kang. Okay. So now I would like to start my presentation. And first, I would like to introduce my research field, the research fields of my research team. And the first is a way study for the water cycle in soil, plant, atmosphere continuum. And the second is a micro irrigation and sprinkler irrigation. Third is drip irrigation with saline water. and the agriculture and vegetation construction in the fields with the saline alkaline soils, and also, the methods for hydraulic analysis and the design of micro-irrigation systems. Also, finally, and for some technologies, and we developed our micro-irrigation systems. And our study is mainly and is dependent on the field experiment. And in the past 20 years, and we have already established about 20 experiment stations, and for the purpose our research and the research project. And now currently we have the 6 stations under operation. That is, the color is in yellow. So as my presentation content is including, the first is the introduction. Second is the methodology and the principle of drip irrigation with saline water. And finally, I introduce the irrigation technology with saline water. As you know, fresh water shortage is a big issue in the world. But there is much saline water resources in our globals. For example, it was estimated that saline water with total dissolved mass content weighing at between 2 to 5 grams per liter. That is means the 6,000 between the 2,000 ppm to the 5,000 ppm is more than the 6 million cubic meter in the North China Plain. That is the region with the most serious issue of water shortage, but it is very important and one of the main grain production areas in China. So there are much saline water resources also in northwest of China. So as agriculture is the biggest water consumer, application of saline water in irrigation can save much fresh water. On the other hand, in some places, if you don't have fresh water, you only have the saline water. So we can use some special technology and for our agriculture. So it's when field irrigated with saline water, salts in the irrigation water enters soil. So salts affect certain soil physical-chemical properties, which may affect the suitability of the soil as a medium for the plant growth. So when we use saline water for irrigation, excessive sodiums and high pH can lead to the soil corrosity, loss of the porosity, and reduce the permeability. So this equation is about the total water potential. So when we use the saline water irrigation, so the osmotic potential is reduced, and then the total water potential will be reduced. That is difficult for the plant roots and the uptake water. So it's under the how to achieve the efficient sedimentation during irrigation to prevent soil accumulation is important. And on the other hand, what technology is more convenient to operation but more precision for practice use, especially for farmers of developing countries. So in the past 17 years, and we have carried out long-term systematic research on the drip irrigation with saline water. And now I'm going to introduce our research results. So in the first, I will introduce why we use drip irrigation. And because drip irrigation is an irrigation method to slowly apply water to crop root zones through emitters installed on or beneath the soil surface. So the features of drip irrigation including water is applied at low rate. So this is important, it's low rate. Water is applied over a long period of time. Water is applied at frequent intervals, and water is applied near or into the plant root zones. So reduce salinity hazard to plants. Why? Because if you use sprinkler irrigation, you should apply water on the canopy. So that may affect the plant growth. But if you use drip irrigation, because you apply water to the soil, not on the canopy, so that can avoid salinity hazard to plant. So advantages of drip irrigation including increased beneficial use of available water, improved fertilizer and other chemical applications, enhanced plant growth and yield, limited weight growth, and decreased energy requirements, and improved the culture practices. And so the surface drip irrigation supplies water frequently from the soil surface to the root zones by point source. So it is possible to determine water application amount according to the crop requirements. If the system is designed to consider the third lynching, third will move downward with the water, and the goal of the third lynching can be achieved. So, because soil water content can always be kept in good condition when we use drip irrigation, and soil moisture potential can be maintained high. Therefore, the total soil water potential can be maintained highly. So if the third concentration in the irrigation saline water is in a certain range, not too high, so crop root can extract the water and the crop can grow well. So by our comprehensive experiment, and we found that the soil moisture potential condition in the main root distribution layer can be maintained when we control the soil moisture potential at 20 centimeter depth and exactly under drip meter. So this is important because why? Because when we use saline water irrigation, so automatically potential reduced. So if we can maintain the soil moisture potential higher, so that the total and water potential will be high. That is, the plant root can uptake the water. But and the other and important is when there is salinity. So sometimes there is the aeration problem. So it's when we use drip irrigation and we control the emitter discharge rate is according to the features of the soils. We can have a good aeration condition, but we can maintain the high soil moisture potential. So and the based on our field and study, and as I said, and we found that we can control soil moisture potential and 20 centimeter depth exactly under drip meter. And then we developed a very simple, but it's a very accurate method for drip irrigation scheduling. That is 10 centimeter is installed at 20 centimeter depth exactly at a drip meter. So irrigation amount for each irrigation event can be set the same. So we can get the value of the soil moisture potential from 10 centimeter if it is reached to the threshold of the irrigation. We just push the bottom to start irrigation. This is for annual crops, and for the perennial crops or trees, we suggested that the 2 centimeter. One is set at 20 depths, another set at 50 depths, and that would be enough for the irrigation scheduling. So, and based on the above results, and we we carried on the saline water irrigation in the four experiment stations in China. And three of the stations located in the semi-humid areas, and one is located in the arid areas. And firstly, we carried on to the experiment in our Tongzhou experiment station is located in Beijing. And for each crops, and we choose the tomato and cucumbers. For each crops, and 25 treatments we designed. So 5 levels of soil moisture potential and 5 levels of salinity content. Is 5 times 5 is 25. So 3 repeats is for one crop is 75, and the plant. It's the smaller plants, and also for the total is we have the 150 the smaller drip irrigation systems for our study. So under the 5 treatment of soil moisture potential is the minus 10 kilopar, minus 20 kilopar, 30 kilopar, 40 kilopar, and at the end 50 kilopar. And we took soil samples, and we also said, tensimeters as shown in these figures. And so 5 treatments of the water salinity at the beginning in the Tongzhou station is the salinity content is between 1.1 DSM to the 4.9 DSM. So as we use the instrument that is the weighing lacimeter, also tensimeter, and also the other equipment, and we observe the soil water distribution, soil distribution, and the plant growth and everything, and we also get evapotranspiration for each treatment. So, and because, in the Tongzhou area, our salinity content is not so high, it's less than the 4.9 DSM. So then we choose another station that is the soil salinity content is from 4.7 to the 10.9 DSM. For the tomato and the cucumber. And for the sunflower and the foxglove, that is from 1.6, this is fresh water, and DSM to the 10.9 and DSM. So then the results shows, and when we engage, when we control the soil moisture potential and 20 centimeter depth is minus 20 kilopars, so that is soil can be lynched there, and plants and growth there. So irrigation amounts you see for the different salinity content is different. That is, as the salinity content is increasing, so irrigation amount is decreasing. That means when we use saline water irrigation, so evapotranspiration is reduced due to the third effect. So we also found the rate of the emergence for Olex sunflower and the wax cones, and the average rate of the emergence was 84% and 93% for sunflower, and for the 88% and 91% for the wax cone. And so if we seed, 2 or 3 seeds in 1 point, so that is the germination rate can reach to 95%. So as for the wax cone and the sunflower, the yield reduction was only 1.4% and 1.7% for each unit above for each unit of 1.6 DSM. And for the tomato water salinity lower than the 4.9 DSM didn't affect the yield significantly, but the relative yield reduced by only at 6.7% for each unit when the salinity content is over the 4.9 DSM. So for the cucumber yield, the yield reduction was higher than the 7.7%, but that is a lot when that is, compared with the previous study results. And we found the taste of the cucumber and the tomato is much improved, tasted very well. So during the 3 years experiment, we didn't find the third accumulation in the soils. And so also we didn't find when the third is reached to the 10.9 DSM. And at the beginning, and because there is a third content in the water, and so in the soil is a third and increase, but quickly is stable. And so for the 3 years, and the third is stable, and there is no increase in tendencies. That means third is linched very well. So the best answer about and study results, and we developed a drip irrigation technology, for example, for the row crops. Because we have the many results, time limited, I only and introduce that for the row crops. So the first with the base fertilizer, manure or component fertilizer is applied according to the initial nutrient content in the cultivating layer. The second is soil preparation. The field is banded and the two beds suggested to be 80 centimeters apart. The band is suggested to be the 60 centimeters wide and 15 centimeters high. So planting and row crop can be double row plotted on each bed. Crop spacing is a 15 centimeter to drip tape. And the entire planted spacing should be determined according to the economical plant density. So mulching is important because, to avoid and the third accumulation on the soil surface. So we suggest bed can be covered by plastic mulcher or straw or the plastic net. So installation of drip irrigation is a drip tape are placed on the center of the raised bed. The emitter spacing should be the 20 centimeter, not bigger. And the flow rate should be determined according to the soil features. So installation of the control hand, main line, subline, and others should be dependent on the hydraulic analysis. So irrigation scheduling, we set 10 centimeter and 20 centimeter depth exactly under drip emitter, and then we maintain the soil moisture potential threshold is minus 20 kPa. So for each irrigation event, 10 centimeter water is enough. So this is in current years, we also applied this technology for the salinity of irrigation water is 6,000 ppm. You see the flower grows very nice. So you see this man, maybe somebody know that he is the Dr. Wahaba, is the vice president of ICID before. Okay. Also, we also developed, technology for reclamation of the coastal saline water, and for agriculture with drip irrigation using saline water. Also, the technology of reclamation of strongly saline soil for agriculture using saline water in arid areas become time limited. I may not introduce here. Thanks for your attention.
Thank you very much. Thank you.